Welcome to Getting Science. In this video, we're going to learn the names of some of the more common elements and their compounds. And we're going to fire up some rocket fuel.
Summer's gone, I'm latching on. Don't even know your name, but you're still in my head. Underneath rays of gold.
All materials that we know of are made up of the elements. And we find the elements all over planet Earth. But did you know that the elements were not made on planet Earth? The elements come from the center of stars, from all over the universe. Which means the elements are basically stardust. So what we're looking at, we could rename as the periodic table of stardust. Let's look a little bit more closely at the first 30 elements. Three important things that we can tell from the periodic table are the atomic number, the symbol, and the name. So for example, element 19 has the atomic number 19, the symbol K, and the name potassium.
So one way you can practice becoming familiar with the elements is simply to make a list like this: atomic number 1 all the way down to 30, their symbol, each one's symbol, and the name. And if you take a second piece of paper, you can cover these things up and just practice. Atomic number 1, hydrogen, element 2, helium, symbol He, and you just practice going down the list until gradually you get familiar. You could even fold a page over like this. So this gives you now, okay, element number 5 is symbol B. What's the name? Boron. Element 12, symbol Mg. What's the name? Magnesium. You can get more creative. Hiding away the symbol. So now you've got the atomic number and the name. For example, element number 11, the name is sodium. What is the symbol? Na. And then you can check if you're right. So if you just play around with these, with the first 30 elements, the whole idea is just to become more familiar with them. Compounds are substances that are made up of 2 or more elements. Here's a list of some of the common compounds that we are going to be talking about and experimenting with during the course of the year. It's important to become familiar with the different chemical formulas. So again, you can use a blank piece of paper just to cover them up so that you can practice. If you want to try and get familiar with the formula for nitric acid, for example, cover it up and see if you can remember it. HNO3. One compound that is not on this list, and probably the most important compound on planet Earth for life to exist, is dihydrogen oxide, otherwise more commonly known as water, H2O.
Water is formed from the chemical reaction between oxygen and hydrogen. Both of these elements are gases at room temperature, but if we mix these gases together and ignite them, we get an explosion that forms the water molecule. The explosion is extremely energetic and extremely rapid, and a tremendous amount of heat is produced. This makes a great recipe for rocket fuel. And in fact, the primary fuel used on the space shuttle was liquid oxygen and liquid hydrogen. The massive orange tank that the space shuttle is attached to is not in fact a rocket, it's simply an external fuel tank. Those two elements are mixed and then injected into the shuttle's engines to provide the thrust. I'm going to build a miniature rocket using a cool drink bottle as my fuel tank and oxygen and hydrogen as the fuel.
Okay, so here's my rocket, my plastic bottle, 2.25 liters. It's obviously already filled with air, so it's already got oxygen in it. All I need to do is get some hydrogen in it and I'll have my fuel mixture. I'm going to do that by using a little bit of hydrochloric acid, which is already in this conical flask,
and I'm going to drop a small piece of magnesium into that acid, which will react, producing hydrogen gas. I'm going to capture the hydrogen gas through this tube, and I'm going to bubble it through a little pan of water. I'll capture it with this funnel. Hopefully that'll work. And then I'll just put my rocket on top, like that. So the hydrogen gas will then bubble up through the funnel into the rocket, and I'll get my fuel mixture, and then the rocket will be ready to go. So the only little problem with this grand scheme is that I have no way of measuring exactly how much hydrogen I'll have in the cool drink bottle. We know, for example, that in every 9 grams of water, only 1 gram is actually hydrogen. The remaining 8 grams is oxygen. So for the best mixture of 2 gases in the cool drink bottle, I need about 11% by mass of hydrogen, and the remaining 89% or so should be oxygen ideally. I'm not going to measure that, so what I'm going to do is I'm going to perform a trial and error experiment, or a Goldilocks experiment. I'm going to start off by putting in just a little bit of hydrogen, probably not enough. I'll then put in too much hydrogen and see what happens, and then I will try and get an amount of hydrogen that's somewhere in between, that will be closer to what would be just right in terms of the correct mixture of the gases for optimal formation of our compound.
You should wear a name tag, 'cause all I wanna do is to know your name. Girl, you should wear a name tag. That's the only way that I get your name. Girl, you should wear a name tag. It's too important to be your name. People go insane when you walk by. Girl, you should wear a name tag.
Goldilocks experiment, not enough. Goldilocks experiment, too much. Goldilocks experiment, just right.